So note that for this question, on the tangent we have a square. On the secant we have just power of 1. So one's even, one's odd. So this is not going to be a typical trig integration with substitution. Now I know that tangent x, if you differentiate that, you get secant squared x. So it would have been nice if it would have been easier, much easier, if that square was here, okay, instead. So you know what? So why don't I try to create some secant squared x? Okay, so I can do that by using the fact that this is secant squared x minus 1. Of course, if you expand this, we're going to still have a problem because now we get an odd power on top of the secant. Okay, so this one here, hopefully you guys remember this one. This is actually the ln of secant of x plus tangent of x. Okay, so this one, I don't know if I should go into the entire proof why this is this, but the basic technique is a little bit tricky. You have to multiply the top and bottom by secant of x plus tangent of x, secant of x plus tangent of x, and then if you let the bottom part equal to u, we can actually arrive here. Okay, so that's almost a separate question, so I'm just going to give you a little hint. So if you don't know, you should try it and see if you can get to here, because me giving you this hint is actually not that hard of a substitution question anymore. Now for this one we have to do it by integration by parts. So we're going to separate into secant of x and secant squared x dx. Okay. Now you let u equal to something that you want to differentiate, and dv equal to something that you know that's easy to integrate. So that's easy to integrate. Right, that's just going to give us v to be tangent of x. So let's let u equal to secant of x, and du is equal to secant of x tangent of x, okay, dx. So this whole thing here can be replaced with secant of x tangent of x. So multiply the u and v, and subtract by the multiplication of this and this, which gives you secant of x, right, and tangent squared, okay, x. This I'm just copying down from the back. Okay, so this should look familiar. This was actually the original question right here. So let me call this a, right? Then I can call that a too. So let me write it. A, the original question, is now equal to this. Okay, of course there's some constant at the end here, or it could be. Now we just have to bring this a over and you get 2a. Okay. So this is one of the tricky integration by parts example. Okay, the final step is to just divide everything by 2. So we have half of secant x tangent x minus half of ln of secant x plus tangent of x, and I'm going to say some other constant here. Okay, maybe constant c1, right? It's just c divided by 2.